Okay, hello everyone. I guess I am audible, and I guess you can see my screen also, right? Uh, yes, this is the fourth class of your Geomatics engineering. Till now, we have covered principles of surveying, errors and their adjustments, maps, scales, coordinate system, distance and angular measurement, distance measurement with help of chain and tape, errors and their corrections, angular measurement with help of compasses, and theodolitic survey, theodolites and all. We have gone through leveling, different types of leveling, and now we have dealt with the trigonometric leveling too, and leveling through theodolite. Next, we have dealt with the traversing and the triangulation survey, right? Traversing, we have dealt with omitted measurements and their problems and all, right? Now let's take a quick look on trigonometric leveling, and now we will go for the theodolitic survey today and horizontal and vertical curves. Yeah, okay. Shall we start the class? Yes, I have dealt the trigonometric leveling yesterday. So I just give a brief discussion, brief introduction of trigonometric leveling, and we will solve one problem on that. Okay. Um, yes. What is trigonometric leveling? It is an indirect leveling. What is trigonometric leveling? It is indirect leveling in which heights and distances are calculated by measuring vertical angle. Indirect leveling, which heights and distances are calculated by vertical angles, right? Yes, there are two cases in this. If my base of the object is accessible and my base is inaccessible, okay? If my base is accessible, I place a theodolite here, and I just, if my base is accessible, then my V vertical height is equal to d tan theta, and RL of Q is nothing but RL of BM plus BS plus V. Okay, these formulas you need to remember. We have discussed these in the last class also. It's just to brush up your basics. Next, base of object is inaccessible, right? So instrument stations and object stations must be at the same vertical plane. If they're at different plane, then what is the case? And my instruments are at the same axis. If my instruments are at the same axis, and if my instruments are not in the same axis also. So you can see my instruments are placed in the same axis, right? So then V is equal to d tan alpha 1, that is equal to d plus b of tan alpha 2. So this one, and this is d tan alpha 1, right? So that is my vertical height, similar triangles. So then d is equal to b tan alpha 2 divided by tan alpha 1 minus tan alpha 2. Next, what will be the RL of Q here? This is Q. What will be the RL of Q here? RL of BM plus BS plus V1. Okay. If my instrument axes are at different levels, you can see my instrument axes are at different levels. Then you can see S2 minus S1 is S. S2 minus S1 is S. That is equal to V1 minus V2, height of the instrument. We'll take it as that is V. What is V1? D1 tan alpha 1. D1 tan alpha 1. What is V2? D plus B tan alpha 2 is V2, right? So from this, the distance D is equal to S plus B tan alpha 2 divided by tan alpha 1 minus tan alpha 2. So how do we calculate RL at Q? This is point Q, RL at Q. It is nothing but RL of benchmark plus S1 plus V1 or V2, whichever is higher, right? Mm, this is the case if my S2 is greater than S1. If my S1 is greater than S2, then what is the case? Then my D is equal to S minus B tan alpha 2 divided by tan alpha 2 minus tan alpha 1. Got it? If this is the case when S2 is greater than S1, when my S1 is greater than S2, then D is calculated using this formula. Okay, let's deal one problem in this chapter. So the horizontal distance between two stations P and Q is 100 meters. The vertical angles from P and Q to the top of vertical tower at T are 3 degrees and 5 degrees. Below the horizontal, the vertical angle from P and Q to the base of the tower are zero point 0.1 degrees and 0.5 degrees below the horizontal respectively. The stations P and Q and tower are in the same vertical plane and also PQ being the same side of T. Neglect the combined correction. They want us to calculate the height of the tower in meters. Okay, so what do we need to calculate H? Hmm? What is H? It from this diagram you can see H is V1 plus V2 or V3 plus V4, right? You can see it here. H. So from the formulas we'll just substitute H. Uh, uh, what is the total angle here? It is given like 5, right? So yeah, we'll do with the total height. I can write this height as d tan 5 degrees plus d tan 0.5 degrees, right? So d tan 5 degrees will be this point, d tan 0.5 degrees will be this point, right? Mm, that is the total height, that is equal to, it is given this is as this b as 100, right? 100 plus d tan 3 degrees plus 100 plus d tan zero point 0.1 degree. So if we calculate 0.0926 d is equal to 5.415 plus 0.04 d, right? So what is its value? 0.042 d is equal to 5.415. So your D is 128.78 meters after calculation. You can check this out. Okay, got it? Next, what they want us to calculate the height of the tower, right? The total height of the tower. So the height of the tower is equal to, we know this thing, right? D, we got it from this. And we know the total angle also. So from this we can calculate, we know this one and we know the, we know this one and we know the angle. We know the theta and we know the distance. Then we can calculate this one, right? So the height of the tower is equal to D into tan of 5 degrees plus tan 0.5 degrees, right? So I know D, substitute it. So my value is 12.39 meters. Okay. So using simple trigonometric formulas, triangulation formulas, we got this thing, right? So this is one of the previous gate problem previously asked to calculate the height of tower when it is at a different level, when my instruments are at different levels. Okay. I hope you understand the problem. Next, we move to tachyometric surveying. In the previous classes, we have dealt with theodolitic surveying, rise and fall method, height of the instrument method. The leveling is up to the mark. We have dealt with the previous problems also. Next, we go with the tachyometric surveying. I have given a brief introduction of tachyometric surveying in the last class too. Okay, let's go with the tachyometric surveying. What is a tachyometer first? Tachymeter is a theodolite in which special diaphragm with top, central and bottom crosshairs between eyepiece and objectives are placed between eyepiece and objectives of telescope. Okay. So the accuracy generally that means when eyepiece is provided inbuilt, the accuracy of tachymeter is 1 in 1000. Okay. What are the systems of tachyometric survey? There, what are the systems of tachyometric survey? There are three systems. Stadia hair method. The stadia hair method is again two systems. Fixed stadia method, mobile stadia method. Fixed stadia hair method, movable stadia hair method. And tangential methods and by special instruments. Okay, what if fixed stadia hair method? Generally, these are all based upon like the ratio of perpendicular to the base is constant when we go with the similar triangles concept, right? So this is the principle under this fixed stadia hair method. So let's look into the stadia hair method fixed. So the ratio, what is the principle here? The ratio of perpendicular to the base is constant. We know it. So if we see, it is like OC by AB, OC by AB, OC1 by A1 B1, OC2 by A2 B2 is equal to constant. Okay. So then my tan beta 2 is nothing but opposite side by adjacent side, right? So what is opposite side? A2 C2 divided by OC2. So this A2 C2, I can write it as half A2 B2, right? As it is a rectangular, as it is a triangle, I can write it as half A2 B2, and OC2 can be written as K into A2 B2. So if we go for that constant k is equal to, after simplification we will get k is equal to half cot beta by 2. Okay. So when will be my k value 100? Just to remember, k is 100 if my beta value is 34 degrees 22 minutes. Okay. So distance formula when the line of sight is horizontal. So you can see the telescopes are placed here. So we can see that, just a minute. Right. The distance formula when LOS is horizontal. LOS is nothing but line of sight. If it is horizontal, then what do we do? So I have Then M is nothing but center of instrument. O, optical center of objective and eyepiece. S, staff intercept. I, stadia intercept. D, distance between optical center and center of instrument. F1 and F2, focal lengths of objective and eyepiece respectively. Focal lengths of objectives and eyepiece respectively. Okay, these are the terminologies here used. MO, distance D. Okay, F1 and F2. So you can see here F1 and F2, S and I. From similar triangles, we can write it, right? F1 by F2 is equal to S by I, right? From similar triangles. And we know that from optics, the formula 1 by F is equal to 1 by F1 plus 1 by F2, the total focal length. So if we multiply with FF1, then my F1 is equal to F plus F of F1 by F2. F plus F of F1 by F2 is nothing but S by A. We have seen up from here, S by I. Okay. Then the horizontal distance, D is equal to F1 plus D. That is equal to F plus, this F1 is here, right? F plus F of S by I plus D. So the final equation is D is equal to K into S plus C. You need to remember this. So what is K? K is equal to F by I. C is equal to F plus D. This F by I is called multiplicative constant. This C is called additive constant. Got it? So you can see here. This is my S1, S2, D1, D2. Like this, the representation will be. Next, let's go with the distance and elevation formula. Okay. When my line of sight is inclined and staff held vertical, then what is my D and V formula? So you can see the D formula is D is equal to ks cos square theta plus c cos theta, and v is equal to ks by 2 sin 2 theta plus c sin theta. RL of q is equal to RL of bm plus h plus v minus r. Okay. When my staff held normal to LOS, then what is your D and V formulas? If my staff is held normal to line of sight, then if it is held normal to line of sight, then my D is equal to Ks plus C cos theta plus R sin theta. V is equal to Ks plus C into sin theta. Yeah, sorry everyone. I guess I got internet issue. I hope you can see my screen now. Is my screen visible? And am I audible? Right. Sorry for the inconvenience. Yeah. So this is the D and V when my line of sight, when the staff held parallel to the line of sight. Okay. Next, movable hair method. We have seen fixed stadia hair method. Now it is movable hair method. Okay, let's go for the nomenclature. P is nothing but pitch of micrometer screw, pitch of micrometer screw. M is nothing but number of rotations. Okay, so you can see I is equal to M into P. Okay, so what is the D? Distance. D is equal to F by I into S plus F plus D from the previous thing, right? If it is fixed. So here my I is nothing but M into P, right? MP into S plus F plus D. So F by P into 1 by M into S plus F plus D. So your D is nothing but D is equal to K by M into S plus C. Okay. This is your equation when you have movable stadia here. Okay. Previously, if it is fixed, then the value is D is equal to Ks plus C. In mobile, we will get another term like K by M. D equal to K by M into S plus C. In this method, the stadia interval is variable, whereas the staff intercept is kept constant. Okay. Stadia interval is variable, whereas staff intercept is kept constant. Okay. Staff intercept is called as base. Staff intercept is called as base. So I guess my screen is visible. Yes. If the base is horizontal, this method is called horizontal substance bar method. Okay. If my base is horizontal, this method is also called as horizontal substance bar method. Horizontal substance bar method. Okay. So let's know this horizontal substance bar method. Okay. So let's check into this horizontal substance bar method. So that means it's nothing like my base is horizontal, right? So let's keep my base as horizontal. Beta by 2. This angle is beta by 2. O. And let's consider this as distance D. This one S by 2. S by 2. Okay. Then horizontal substance bar method. Then tan beta by 2 is equal to S by 2 divided by D, right? So what is my D? S by 2 tan beta by 2. When beta is taken in degrees, okay, then my D is equal to S by 2 into beta by 2. Okay. So I can write it like S by beta into 206265. Then my beta is in seconds. Okay, if beta is given in seconds, then this is your formula. And this is the formula if beta is given in degrees. It is used for the measurement of distances and elevations on slopy grounds. It is accurate for long sides also. Okay. This is used to measure the distances and elevations on sloping grounds. And it is accurate for long sides. Next, effect of angular error. Effect of angular error. So this is nothing but D is equal to S by B. We have seen it, right? So let's differentiate it to minimize the error. We know that square into eta B, that is equal to minus 1 by beta into S by beta into dB, right? d beta. So my differentiation value is beta by beta. So you can see this. The positive error in d beta will produce a negative value of d, and vice versa. Got it? This is the effect of angular error. Next method is tangential method. Okay. In this method, the readings corresponding to crosshairs are not required. Tangent staff is used for taking the vertical angles on the vanes fixed to the staff. Got it? No crosshairs required. Target staff is used. Target staff is used for taking vertical angles. Vertical angles on the vanes fixed. Got it? So this is the tangential method. So in that there are three cases. If both are angle of elevation, both are angle of depression. One is angle of elevation and one is angle of depression. Okay. If my both is the angle of elevation, you can see if my both is angle of elevation, then V is equal to d tan alpha 1. V plus S is equal to d tan alpha 2. We know it from simple triangulation formulas. Yes, then my D is nothing but S by tan alpha 2 minus alpha 1. Next, what is RL at Q? RL plus RL of BM plus height plus V minus R. So if it is in height, we have considered all this thing. So this has to be minus, right? So minus R. Next, both are angles of depression. You can see both are angles of depression. Then my V is equal to d tan alpha 2. V minus S is equal to d tan alpha 1. From this, your D is nothing but S by tan alpha 2 minus tan alpha 1. And what is RL? RL of Q is equal to RL of BM plus H minus V minus R. Okay, as it is depression. Next, one angle one angle of elevation and one angle of depression. You can see one angle of elevation and one angle of depression. Then V is equal to d tan alpha 2. V is equal to d tan alpha 2. S minus V is equal to d tan alpha 1. S is equal to d tan alpha 1 plus tan alpha 2. From this you got d as S by tan alpha 1 plus tan alpha 2. What is the RL of Q? RL of Bm plus H minus V minus R. So these are the trigonometry. These are the methods for these are tangential methods, formulas for tangential methods. Got it? Next, let's move into. I have already told you. Um, Next method is special instruments. Special instruments. So the special instruments methods include Beeman's Stadia arc, Jeffcott direct reading tachometer, rangefinder. Okay, so these special instruments are used to calculate this vertical angles. So Jeffcott direct reading tachometer. This instrument has a special diaphragm and is fixed with fixed pointers and mobile pointers. Okay, from that we will calculate the horizontal and vertical distances. As I told you, it has special diaphragm fixed with fixed pointer. The pointer is of red color. You need to remember it. And mobile pointers are blue and black. Now, horizontal distance is nothing but difference in the readings of blue and red pointers into 100. Difference in readings of blue and red pointers into 100. Got it? Next, vertical distance. So how do we calculate the vertical distance? It is nothing but difference in reading of black and red pointers. Difference in readings of black and red pointers into 100. Got it? So these are from these values you can get the horizontal distance and the vertical distance. Next, range finder. What is range finder? It is suitable for inaccessible points between which the distance can be measured. Okay, it is more suitable for targeting the objects of height above 500 kilometers. If my points are inaccessible, so I want to measure the distance between the points, then we use range finder equipment. Okay, generally it is suitable for targeting the objects at a height of 500 kilometers. Next, gradienter. It is used for setting out grades in tangential method of tachometry. Okay, it is used for setting out grades in tangential method. Next, ohmnimeter. It is nothing but a special tachometer invented by Echo Hold and is used for tangential method of tachometry. Okay, tangential method of tachometry. So these are the special equipments. Next, we'll solve some previous gate problems. Okay, it is given the focal length of the object glass of a tachometer is 200 mm. That means F is 200, and the distance between the vertical axis of tachometer and optical glass is 100 mm. That means D value is 100 mm, and the spacing between the upper and lower line of the diaphragm are 1, 2, and 3, with the line of columnation perfectly horizontal. Okay, the horizontal distance between the strap and the instrument. So this is perfectly horizontal means it is a fixed stadia method. So what is your formula to calculate the distance? Distance between 2 points, it is nothing but D is equal to Ks plus C, right? F by I into S plus F plus D, right? So in the problem, it is given focal length is 200 meters and I as 4. And how do we calculate S? It is given the diaphragm axis is at 1, 2 and 3. It is nothing but the difference of this 2. So I have written 3 minus 1 plus difference of 2 levels. Focal length is 200 and the distance is 100 mm. So I am converting it into meters. Okay. So what is your value? It is nothing but 100.3. So 100.3 meters. Got it? I guess you understand this. Next question. Let's deal with the next question. In a tachyometric survey, the readings of three diaphragm webs on a staff held normal at a point were recorded as 0.65, 0.65, 0.99 and zero point 0.1 and 1.32 mm. Additive and multiplicative coefficients, they have given C and K. Coefficients are given respectively. RL of the instrument station is 25.25 meters. Height of the instrument they have given. They're asking us to calculate the RL of B. Okay, let's draw the diagram first using this thing. Let me erase. So let's first draw the diagram with the data. He has given three diaphragms at a normal distance. So let's check. He has given three diaphragms, right? So 1, 2 and 3. It is 1.32, 0.99, 0.65, right? And height of the instrument is given 1.45 and RL 25.25. What they are asking us, they are asking us the RL at B. Okay, so RL of B is equal to, how much is that? First, this RL at A plus 25.25 plus height of the instrument, right? 1.45 minus, we need to take this one, right? 0.99. It is nothing but 25.71 meters. Got it? Next. So to confuse you, they have given all these things. You just need to take the parallel value. Okay, this is the twist here. Next, the vertical angles of vanes fixed at 1 meter and 3 meters above the foot of the staff held vertically at station Q were 2 degrees 48 minutes, 5 degrees respectively. The horizontal distance and the RL of Q respectively if the elevation of line of collimation is 203.51 meters. Okay, they're asking us to calculate the horizontal distance and RL, right? So let's draw the diagram first. So they told us like, okay. This is the height of instrument. So this is your V, and they have given this angle 2 degrees 48 minutes, and this angle as 203.51, right? What they're asking us to calculate it D and V values. So what is V value? V is equal to, this is the D distance, horizontal distance. V is nothing but D tan 2 degrees 48 minutes. Next, V plus 2. So they has given this as 2 meters. V plus 2 is equal to D tan 5 degrees. So this is the RL. I have written it here, right? So RL is 203.51. Okay. So these are the two, and from this two, by solving we can get D is equal to 51.84 meters. V is equal to 2.535 meters. Got it? Next, what they have asked, they have asked to calculate the horizontal and vertical distances, and next RL. RL at Q is equal to, first RL at A plus height, so 31 plus that height, V minus 1. So 205.045 meters. This is your RL at Q. Got it? This problem is done. Next, to determine the distance between 2 points P and Q and elevation of Q, following observations were made. The height of tachometer at P is given, the vertical angle at P is given, and the staff reading is equal to, the staff reading with vertical staff is equal to, they have given 3 readings, and the RL of P. So first, we know that we can calculate the, if the staff is vertical, then my S is highest minus lowest, 2.265 minus 1.145, right? And it is inclined. So here comes the second case, right? If it is inclined, then what is our distance equation? Distance is equal to that okay, let's substitute 100 into 2.265 minus 1.545 into cos square. What is that angle? 4 degrees 25 minutes 20 seconds. 71.572 meters. Next, V, they have asked D tan alpha. What is alpha? 4 degrees 25 minutes 20 seconds. So this is 5.535 meters. Next, they have asked to calculate RL of Q. Okay, what is RL of Q? So what is this RL at A first? Reduced length of P is 123.25 plus V we need to calculate minus this distance. This, the horizontal distance is 1.95, right? And height of tachometer is given. So minus H and minus V, yes. So first RL of Q is equal to RL at P 123.265 plus height, it is given 1.28 plus V minus 1.905, right? So substitute V value here, 123.265 plus 1.28 plus 5.535 minus 1.905. The value is 128.77 meters. Got it? So these are your previous questions, previous gate problems we have solved. So what is the value? It is 128.17. So option B is your answer. This is gate question, previous gate questions these are. So here comes in this model. So here ends your tachyometric surveying. Now let's enter into another topic called curves. Okay, so what are curves and why do we need them in civil engineering? Curves are used to change the direction of highways and railways. Okay, so that's why we use to survey curves. Curves are used to change the direction of highway or railway. Got it? The curves are generally classified as horizontal curves and vertical curves. Okay. The horizontal curves are again classified into simple curves, compound curves, reverse curves, and transition curves. So these are all comes under horizontal curves. Simple curves, compound curves, reverse curves, and transition curves. Next, what are vertical curves? Vertical curves, summit curves and sag curves. Summit curves, sag curves. Okay. So let's check into simple curves. Let's discuss few topics and the terminologies of simple curves. It is nothing but the arc connecting two straight points. Okay. Simple curves are nothing but the arcs connecting two straight points, two straights. Okay. Let's check with the terminology. What is T1? T1 is nothing but the point of curve. V. V is nothing but the point of intersection. T2, point of tangency. Okay. So what is point of curve? Point of curve is the one where straight line becomes curve. Okay. These are generally asked one mark questions. Point of curve. Where straight line becomes curve is the point where the straight line becomes curve. Next, what is point of tangency? Point of tangency. Point of tangency is where the curve becomes tangent. Point where the curve becomes tangent. And point of intersection. Point of intersection. It is nothing but the intersection of two tangents. Intersection of two tangents. So what are the two tangents here? VT1 and VT2. Intersection of the two tangents VT1 and VT2. Okay. So next, AT1 is called the back tangent. AT1 is called the back tangent. BT2 is called the forward tangent. BT2 is called the forward tangent. Next, intersection angle. Intersection angle. So it is the angle between the two tangents VT1 and VT2. Angle between two tangents VT1 and VT2. Got it? Next, deflection angle or deviation angle. Deflection angle or deviation angle. It is represented by delta. It is nothing but it is equal to 180 degrees minus intersection angle. Got it? Next, normal chord. What is normal chord? The chord between the two successive regular stations on a curve is called normal chord. Okay, it is nothing but it is equal to the peg interval also. Two chord between two successive regular stations. It is equal to peg interval. Subchord. It is a chord shorter than normal chord. Got it? Next, let's look into few designations and the designations of curve. Okay. So first topic is designation of curve, degree of curve, and elements of curve. What is designation of curve? This is an important question. Designation and degree. Designation is nothing but the sharpness of the curve is designated either by its radius or by its degree of curvature. Okay, that designated either by its radius or degree of curvature. Okay, so this is D, this is R. This is your arc, this is your chord. Got it? So this is nothing but degree of curve. This R is nothing but radius of curve. Got it? Next, degree of curve. What is degree of curve? It is the central angle of the curve subtended by an arc or chord of fixed length. Curve is designated by its radius in UK, but it is designated by degrees in US, Canada, and India. Okay. degree of curve. It is the central angle of curve that is subtended by an arc or chord of fixed length. Okay. So for 30-degree arc, then what will be my relation between radius of curve and the degree of curve? For 30 meters arc, that means 30 meters is my perimeter, right? Then what is the radius, relation between radius and degree? It is 1718.9 divided by t. For 20 meters arc, then my relation between r and d is r is equal to 1145.9 divided by d. Got it? Next, elements of simple curve. Let me erase this. Elements of simple curve. So what are these elements is one tangent length, one tangent length. So how do you calculate the tangent length? It is nothing but Vt1 and Vt2 is equal to R tan delta by 2. Next, external distance or apex distance. External distance or apex distance. It is nothing but V that is equal to R into secant delta by 2 minus 1. Next, mid-ordinate or versed sine CE is equal to R into 1 minus cos delta by 2. Next, length of long chord. Length of long chord. It is nothing but T1 C2 T2 is equal to 2R sine delta by 2. Next, length of the curve. So you all know the formula for length of the curve, right? It is nothing but L is equal to R into D or theta or delta. It is up to you. Okay, the nomenclature is up to you. R into delta, right? Like delta is in radians. If it is in degrees, then what it is? Pi R delta by 180. If my delta is in degrees. If it is in radians, L is equal to R into theta, right? The angle subtended by it. So for 30 meters arc, what is your L? So pi delta by 180 into, we know that R relation 1718.9 divided by D. So 30 delta by D is the length of the is the length for 30 meters arc. Got it? Similarly, give me the length for 20 meters arc. It is nothing but 20 delta by d. Got it? So if you remember these formulas, they will ask you calculate the necessary data for setting up the simple curve. They will give you the chainage, how many chains and how many links, the radius of the curve, deflection angles, peg intervals. Then they want you to calculate length of the tangent, length of the curve, chainage, chainage at T1 and T2, least subchord length, number of chords, like that. Okay, those problems will be asked. Next, let's check into methods for setting out curve. What are the methods and how do we set a curve while surveying? There are two methods for setting out a curve. They are linear method and angular method. Okay. So what is this linear method? Let's check into this. So you can see the offset from the long card formula from this. R minus, this is your R, this is your R minus root of R minus L by 2 square. Okay. OX, it is offset on X, offset X is nothing but OO minus X square by 2R. Oh, sorry. OO is the distance from the center point to the point on the curve. OX is the distance at X on the curve. Next, perpendicular offset from tangent. Perpendicular offset from tangent which is at a distance of X. Then O1 is equal to X square by 2R. So you can see O1, O2, O3 is nothing but O1. O1 is like C1 square by 2R. O2, C2 square by C2 by 2R into C1 plus C2, O3. So like that ON is equal to Cn by 2R into Cn minus 1 plus Cn. Okay. So this is linear method, and next angular method. So angular method is nothing but Rankes method of deflection angles or method of tangential angles. Got it? So tangential angle delta is nothing but if my curve is 20 meters, 30 meters curve, then you know that delta is equal to 1718.9 into C by R, right? So in minutes, we know delta 1, delta 2, delta 3. So you can just calculate it. And next delta 9. From this you can see like deflection angle delta is equal to alpha 1. Delta 2 is equal to delta 1 plus D2. It's not that D, it is okay. They have designated it with D. Delta 3 is equal to, so if we go with the angular method, then these are the deflection angles. Got it? So let's deal some previous grade problems. A circular radius, a circular curve of radius 180 meters is to be set with a long chord 60 meters. The length of the middle coordinate in meters is. So you have seen the formulas, right? They are asking length of the middle coordinate in meters. So what is the formula? I have written, maybe I have erased it. Okay. Length of the middle chord OO is equal to R minus root of R square minus L by 2 whole square. I have dealt this while setting up the right simple curve. I have dealt with this formula. Okay. So what is given R? 180 meters minus root of 180 square minus L by 2 square. L is 60, right? 60 by 2 whole square. On simplifying, the value is 2.52 meters. 2.52. Next, two straight lines deviate at an angle of 60 degrees. The radius of curve joining the two straight lines is 600 meters. The length of long chord and the mid ordinates in meters of the curve are. They're asking length of the long chords, right? Length of the long chord, we have dealt it here only, right itself. Length of long chord, 2r sine delta by 2, right? And mid ordinate, r into 1 minus cos delta by 2, right? So you just substitute your values in these formulas, then you will get length of long chord. L is equal to 2r into sine delta by 2. So 2 into what is your r? 600 meters, right? 600 into sine. What is your delta? 60 degrees. 30 by 2. Sorry, 60 by 2. 30. To sine 30. Sine 30 is half, right? So what is your value? 600 meters. Next, they are asking the mid-ordinate in meters. So what is the formula for mid-ordinate? Okay, let me erase this. What is the formula for mid-ordinate? Mid-ordinate is equal to, we have seen r into 1 minus cos delta by 2, right? So r is 600 meters, 1 minus cos 60 by 2, 1 minus cos 30. So what is your value? 80.38 meters. So 680.38. So this is your formula. This is your option B. Got it? These are gate previous questions asked in curves. Especially we have dealt till now horizontal curves. Let's check into vertical curves now. Okay. So we have dealt in the previous session. The vertical curves are again divided into two parts: summit curves and the sag curves. Okay. Summit curves and sag curves. So what is a summit curve and what is a sag curve? If my gradient, positive gradient is followed by negative gradient, then it is a summit curve. Okay. So what are vertical curves first? Where do we use vertical curves? It is used to connect two different grade lines of railways or highways to smooth out the changes in vertical motion. Got it? This curves are nothing but like parabola or circular arc. Let me write here. Used to connect two different grade lines of railways or highways, okay, to smooth out the changes in the vertical motion. So this curves will contribute for the safety, comfort, and appearance of the passengers. Contributes for safety, comfort, and appearance. Next, they are generally parabolic or circular ones. Parabola or circular arc are best suited for vertical curves. Okay. The rate of change are best suited because the rate of change of grade is uniform. Because rate of change of grade of these curves is uniform. Got it? So now let's take a look on summit curves. If my positive gradient is followed by negative gradient like this, my positive gradient is followed by negative gradient, and next my positive gradient is followed by another positive gradient, then the curve formed is also called as summit curve. And if my negative gradient is followed by negative gradient, you can see negative gradient followed by negative gradient. Then what are sag curves? You can see they are like sagging. Summit curves, hogging, like. So if my negative gradient is followed by positive gradient, then it is a sag curve. You can see if positive gradient is followed by negative gradient, then it is a summit curve. If my negative gradient is followed by positive gradient, then it is a sag curve. Okay. And if my negative gradient is followed by negative gradient, if positive gradient is followed by positive gradient, these are the types of sag curves. Got it? Next, we deal with the length of vertical curve. So how do you calculate the length of vertical curve? In previous case, length of horizontal curve. How do you calculate the length of horizontal curve? It is nothing but L is equal to R into theta, right? The angle made between the two chords joining the arc. Here, the length of vertical curve is given by L is equal to G1 minus G2 by R. Okay. So what is R? R is nothing but rate of change of grade. Okay. So what is R value? R value is 0.06% per 20 meters for first class railways. That means the speed is 150 to 300 kmph. My R value is 0.03% per every 20 meters for second class railway. That means my speed speed of the train on that track on that curve is less than 150 meters, then my rate of change of grade is 0.03%. Okay, now let's deal with a problem. If two grades, let's do a problem. If two grades of plus 1.2% and minus 0.9%, these are the two grades G1, G2, meet to form a vertical curve. I want to know the rate of change, and the rate of change of grade is rate of change of grade R is equal to 0.1% per 30 meters. The length of the vertical curve is, they're asking us to calculate the length of vertical curve. So what is the length of vertical curve? G1 minus G2 by R, right? So what is G1? They have given 1.2. What is G2? Minus 0.9 divided by R, 0.1 for every 30 meters change. So after simplification, the answer is 630 meters. Okay, like this problems are asked from this topic. Next is the transition curve. So what is transition curve? A curve of varying radius and varying curvature introduced between the tangent line and a circular curve between two branches of compound curve are known as transition or easement curve. So if there are sudden change of curvatures, then we can't go with the sudden change of slopes, right? So for to facilitate the transition, there is a varying curve joining these two branches. That curve is nothing but transition curve. Got my point? Curve of varying radius and curvature introduced between tangent length and circular curve. Tangent length and circular curve for smooth transition. Okay. So what are the advantages of transition curves? Advantages. So it always follow a gradual transition of curvature from the tangent to the circular arc or from the circular arc to the tangent. Okay, so that there is easement in our transition. The radius of curvature increases or decreases gradually. And it is provided for the gradual change in the super elevation in a convenient manner. Okay, it eliminates the danger of derailment, overturning, sliding, sloping of vehicles and discomfort of the passengers. So these are all the advantages. They will ask you sometimes, like what they have given statements, and they will ask which statements are correct, or pick the wrong statements. Like that, they can include the advantages in that, and they will ask you a theory bit from this part. Okay. Next, super elevation or cant. You heard about it. Super elevation or cant. So I think you all heard about it in transportation engineering also. Super elevation or cant, right? So what is super elevation or cant? It is nothing but when we are going in a curve, when we are traversing in a curve, uh, there may be the centripetal forces and centrifugal forces are not balanced. Then to balance these forces and for the safe movement of the vehicle, what do we do is we will increase one side of the road to counteract the centripetal force or centrifugal force, right? That elevation of the road is nothing but your super elevation. This also be called as cant. Okay, the degree to which it is raised is nothing but cant. So let's take this as a vehicle traversing a sloped ground. Then this is the way it will act always normal, and this is the P, and this is your normal reaction. Then we need to calculate the height is it is to be raised, or elevation it is to be raised. So from this, tan theta is equal to P by W, right? We can write this P, angular velocity, V square by 2g. Okay, here it is written as V square by RG. That is nothing but the h by, let's take this distance as B and this distance as h by B from similar triangles. Then h is equal to PV square by RG. So this distance is nothing but the distance between these two tires, 2 points. If it is in railways, this is the distance between two gauges. Then it can be taken as gauge length. This is in roadway. If it is in railway, it is GV square by RG. Here G is nothing but the gauge length, distance between two gauges. Okay. Centripetal ratio, centrifugal ratio, sorry. Generally, if it is not given the centrifugal ratio, this P by W is 1 by 4 for roads, 1 by 8 for railways. Got it? Next, let's go through few formulas. Design speed, design speed, or hands of velocity, hands of velocity. The speed of vehicle in the absence of frictional force. That is nothing but the speed of vehicle in absence of frictional force. Speed of vehicle in absence of frictional force. Okay. So tan theta plus phi. Phi is nothing but angle of friction is equal to V square by Rg. We know it. So I am saying that angle of friction is 0. Then V is equal to root of tan alpha into Rg, right? So this is the design speed or the speed of vehicle. This is hands of velocity. Next, length of the transition curve. Length of transition curve. Okay. So if it is like it is in slope 1 by n, okay, by rate of super elevation first. By rate of super elevation. Tell me my length. Length is equal to n times of h. You know it, right? 1 by L is n is equal to h by L, similar triangles. that is equal to n into what is hbv square by rg or gr, right? V is velocity in meters per second. If it is in kilometers per second, you need to convert it. Okay. First, by rate of super elevation, this is your length of transition curve. Next, second point, by time rate. Okay. Let the time rate of application be x centimeters per second, and let the super elevation be h centimeters and the speed be v meters per second. Then what will be the length? Length is equal to velocity into time, right? So I can write this t as h by x, distance traveled, right? So my L is equal to b, I am substituting h, b v square by gr, right? B v cube by r gx. This is length of transition curve by time rate. Next, length of transition curve by rate of change of radial acceleration. 3. Rate of change of radial acceleration. So it is the most efficient method. So you can say this, oh, this is your curve. It is in transiting, it is parallel, is the tangential acceleration. Normal to the curve is radial normal acceleration. This is your tangent and this is your normal. Okay. So radial acceleration, an is equal to v square by r, right? So rate of change of radial acceleration. Rate of change of radial acceleration. Alpha is equal to an by t, right? So this is nothing but v square by r into t. So now let's do the length. We need to know the length of transition curve, right? Length of transition curve. So L is equal to, as you know, it's nothing but v into t, right? So let's substitute here v into, so t is equal to alpha into r by v square. Alpha into r by, oh sorry, t is equal to v square by r alpha, right? So v into v square by r into alpha. So it is nothing but v cube by r alpha. So the length of transition curve considering the rate of change of radial acceleration. This is the formula. L is equal to v cube by r alpha. V is in meters per second. Okay. Rate of change of angular acceleration. So there are few empirical formulas. Okay. Empirical formulas are nothing but the formulas which are experimentation values, which we have done a lot more experiments and we have come to the conclusion with the constants, right? So if my alpha, rate of change of angular acceleration, is 0.3 meter per second square, okay, by rate kada, meter per second square by rate experienced, then the comfort, for the comfort, if my alpha is that, for comfort, my length of transition curve will be L is equal to V cube by 14R. V is in kmph. Got it? This is one empirical formula. It is given by Mr. Short. The ideal transition curve is called ideal transition curve is called clothoid or cubic spiral. Okay, this is one of the most ideal transition curve. This is one important previously asked Kate problem, repeatedly asked. So yeah, let's deal with one problem before winding up the class. So they're asking what is the length of transition curve if speed of vehicle is 60 kmph, rate of change of angular acceleration is 0.3, and the radius of curvature is 300 meters. Okay, they're asking us the length of transition curve. How do we calculate length of transition curve? So from that formula, it is nothing but V cube by 14 into R, right? So 60 cube by 14 into R is 300. So your value is 51.43 meters. Like this we will deal. So till now we have covered curves, both horizontal and vertical curves. We dealt with the previous gate problems also. Okay, fine. Next, let's wind up the session for today. Thank you for your patient listening.